additional overheads. So now let's go ahead and let's add a new employee. Now this time let's check what happens. Now notice only one parameters constructor call was made, one copy constructor call was made, and one destructor call was made. Now the reason why this happened is the previous time the vector was resized, C++ was a little smart. It resized it to hold more than one element. So it was expecting us to push another employee soon, so it allocated memory sufficient for 2 employees. So therefore we only have one copy constructor call. But now let's try to add the third employee, and notice we are back to the same problem as before. All the previous employee needs to be, first the vector needs to be resized, so you need to have sufficient memory to hold all the new employees. All the previous employees needs to be copied to their new locations using copy constructor and then destroyed. And finally, the last element that we are pushing will also be copied and destroyed. So this problem is persistent. So if you keep adding employees one at a time, then you will have this polynomial number of copy constructor and destructor calls that can be time consuming. Now first let's print the new employee to just verify that we added Dave properly to our employee management system. Okay, so notice now Dave, Ryan is the last employee that was added. So we have Dave, Brad, and Ryan. That's the last 3 employees that are printed in the employee list, the employee vector. Now a better way to do this is there are a few different ways we can avoid this additional copy constructor destructor calls. I'm showing you the simplest way here. The simplest way is to first declare a vector called employees. It again holds an employee class object. But first I'm reserving memory that says that I have at least 100 employees that I expect to be part of my organization. So here in the beginning, I'm allocating memory that is sufficient for 100 employees, and our vector now can store at least 100 employees before it needs to do the copy constructor destructor cycle to make more space for new employees and then copy back the old employees. Now with this, what happens we will see. Let's just go ahead and run this. Okay. So notice now I'm using a new method called emplace_back. Emplace_back is similar to pushback. The only difference is you can use in-place construction of objects. With pushback, we were creating a temporary object and then copying the temporary object using a copy constructor, then deleting the object. So there were 3 calls made. Now instead, if you use emplace_back, you will only construct this object directly inside the vector by calling a parameterized constructor. So now we have simplified from our previous code. We are only having 5 parameterized constructor calls to add our first 5 employees into our employee management system. So there is already a good reduction. Now again, let's print our new employees just to verify that everything is going fine. Notice again, we can print our employees back. Now let's see what happens when we do add employee. Again, I'm creating a temporary employee, so a parameterized constructor destructor was called, and at the end, only one copy constructor call was made. Now, since our employee vector has enough memory to hold 100 employees, we don't have that vicious cycle of resizing our vector, copying the old elements back, and then adding a new element. So this is one way you can reduce the number of calls to constructor and destructor. This is still not optimal because a priori we are allocating a lot of memory. Maybe our organization has only 10 employees and we don't need this additional memory that holds space that can add up to 100 employees. So this is the downside of this approach. There are other approaches which are a little more complicated, so let's not go into it. Now let's just finish this employee management system by looking at what is this find_employee method. So suppose we want to search an employee by name, how to do this with our class. Notice now all I have to do is declare a temporary employee in the main function and pass this temporary employee into our method find underscore employee. Suppose our method find underscore employee finds the employee within the vector of employees. We can fill the found employees information into this temporary object that we are passing, and then use the get methods to print it on the main program. So again, the return type is the same. If find underscore employee finds this employee that we are searching for in the vector of employees, it will return true. Otherwise, it will return a false. Now again, the body of this find employee method should be very simple. All we are doing is using the range based for loop to iterate through all the employees. We will use get underscore name method to get the name of an employee and check whether it is equal to the name that we are looking for. If it's equal to the name that we are searching, we will use copy assignment to copy the correct employee information into the variable that we have passed from the main program, and we will return true. So now let's execute this and let's see whether we can find Rick in our vector of employees. Okay, so notice again Rick was found, and all that happened here was let's see, there were a few yeah, so all these destructor calls happened only because I allocated memory for this temporary variable employees within this particular scope. So since I created this new scope and then created variables within the scope, once we exited from the scope, all of them were deleted. So find employee call did not create any new memory. All it did was loop through the employee vector and searched for our the employee that we were looking for. The only thing that our find employee method did was use copy assignment to copy the found employee. Finally, let's just look at Jim-Bob. We know that Jim-Bob is not part of our vector of employees, so we should not find him. So our find underscore employee method should return a false, and we see that employee Jim-Bob is not found. So this completes again this program on the employee management system using classes. Now we saw that with classes, we overcame some of the challenges that we discussed at the end of the previous design, wherein we had issues like there were multiple vectors, one for each attribute that described the employee. You could have issues like not all vectors will be of same size. The program still compiles, but then at runtime you will face runtime crashes. You can mix up different vectors which are of the same type while you're passing a function, and you will probably not notice this for a very long time, and such issues can be really hard to find when your program becomes longer and longer. All these issues were solved by creating an employee class wherein we encapsulated all the information related to an employee within this employee class. The methods print underscore employee, find underscore employee, add underscore employee also were simplified. We only need to pass one vector of employees now instead of passing one vector per attribute. And we also saw how to use operator overloading with classes to simplify the print statements, so we can directly print an instance of our class by overloading the less than operator to print information about an employee. So using classes makes your life simpler. The code is more organized. So I can just look at the declaration of a class to see what are the attributes that describe an employee. I can look at the methods or the member functions of the class to see what are the member functions that can be used to access these data members. And with classes, you also need to pay attention to how memory is being allocated and destroyed. So if you don't pay attention to the constructor and destructor calls, it can lead to issues that will be really, really difficult to debug and find out. So suppose we already saw one such problems that if we are using vectors to store user-defined objects and we don't pre-allocate enough memory for our vector, C++ internally will keep resizing the vector, keep calling copy constructor and destructor, which can be which can make your program really slow. So there are some downfalls also by using classes. The downfalls are smaller than the advantages that we get by using classes. So it's recommended to use classes, but you should be careful and you should know what internally C++ is doing to use it properly. So I hope this class was useful for you to get an introduction to classes in C++. Next, we will see if time permits, we will go through some advanced concepts like polymorphism and templates that will make the use of classes even more useful when we are writing more advanced programs in C++. Thank you.